The James Webb Space Telescope is the largest space telescope ever built. Its tennis court-sized sunshield, along with its 21-foot 3-inch primary mirror, will enable Webb's instruments to see back in time to when the first stars and galaxies formed after the Big Bang, more than 13 billion years ago. But Webb's size is too big to fit into any existing rocket, so it's designed to be folded like origami, so it fits inside the almost 15-foot wide payload fairing of the very powerful Ariane V rocket. Once in space, the Webb Telescope is slowly unfolded in a well-choreographed series of deployments. The solar panel is deployed first to provide power. About 12 hours after liftoff, Webb's thrusters are fired in what's called a mid-course correction burn to fine-tune Webb's trajectory. About 24 hours after liftoff, Webb's high-gain antenna is deployed, enabling communication with ground controllers. Webb is traveling so fast, it passes the moon in about 2 days. Here, a second mid-course correction burn sets the spacecraft on course toward its orbital destination. On day 3, special pallets holding Webb's folded sunshield deploy. First the forward pallet, then the aft pallet. Webb's central tower is extended, lifting Webb's telescope and instrument package to its operational location. Webb's momentum flap is deployed. As the sun's solar pressure pushes against Webb's large sunshield, this flap helps stabilize the telescope. Special covers hold Webb's tennis court-sized sunshield in place during launch. These covers are now released, freeing the sunshield for deployment. The first of Webb's sunshield mid-booms deploys, unfolding and extending one side of the 5-layer Kapton sunshield. Then, the second sunshield mid-boom deploys. Once both booms are fully deployed, the center rim is deployed, and the sunshield is slowly tensioned. This separates the 5 layers. On the sun-facing side of the telescope, a radiator shade deploys to protect Webb's spacecraft systems from the sun's heat reflected off the sunshield. Near the 10-day mark, the MIRI instrument's cryocooler is started. It begins lowering the MIRI instrument's temperature to about 6 degrees above absolute zero. Controllers now begin the process of deploying Webb's optics. Webb's secondary mirror deploys first. Then, an additional radiator panel behind the telescope deploys. This helps remove more heat from the spacecraft. About 12 days after launch, the first wing of the primary mirror is rotated into place. A few days later, the other mirror wing is rotated into place. About 30 days after launch, another mid-course correction burn further tunes Webb's course toward its final operational orbit, about 1 million miles away from Earth. For the next several months, optics engineers using Webb's NIRCam instrument will align and focus Webb's 18 primary mirror segments into a perfect monolithic mirror. It will take about 6 months before Webb is fully ready to capture its first science image.